Hmm. So I was shifting the network. I was shifting the network. How is it now? I changed the network. How is my audio and video now? Is it lagging still? Give me a moment. I'll allow that, Nela. For me, today basically I'm doing the Zoom in a different. See, I'm doing the meeting in a different Zoom. So that is why I think I'll got that sound. Okay, because normally that sound should come only to me, not to you all. That's a strange sound. I actually need that sound, but anyways, because it's disturbing for you all, let me off it. Paune. I all even Pau. All or not. So I was shifting the network. Or shape. And I again change the network now. Which mic company? So yeah, I was dancing and the third network. No, I hope this is fine. Mic testing 1, 2, 3. Okay, now mic is okay. Speaker is also okay. Yeah, perfect. Let's start. Who's Zoom? I'll tell later. Hmm. So basically, I shared the paper in the chat, and that paper only I'm going to discuss now. So basically, um, now in my normal Zoom, you can put only 100 people. Still sucking? Can't be. I changed the network. This network 1, 2, 3. No, in my phone it looks good. It switched on the video. Still it like that. I have off that Anuska, don't worry. Okay, perfect. Let's start. Let's start. Ta-dun, 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 ta-dun. Yeah, Ivan. That is basically my mind is processing data. When my mind is processing, that's how you might hear. I mean, yeah, it's unintentionally ping pong. Okay, let's start. Let's think about it, Amra. Not needed for now. Okay, let's start. What is Amra? Yeah, we're gonna start now. Um, so yeah, a while ago I shared all the paper as well in along with the Zoom link. So that's what we're going to start now. So let's start now. The e-government services with the examples using numbers and labels. Okay, let's do it. Do we need to write? I thought you all already did the paper. So if you all did the paper, you all can mark the answers. Or else, yes, you can use a paper class writing book. I asked you to use a separate writing book paper class, right? You can use that here and right there. Okay. So match the e-government service example using numbers and labels. So they have given here four e-government services. G2G stands for government to government. G2B stands for government to business. Circulars, right? So these gazettes and circulars are like government notices. For whom do you think these government notices are going to be useful based on the given scenario? Is it one, two, three, or four? You're still lagging. I'm going to kill this network now. Wait, we just double check. Um, that will never happen, Sala. Amber, why did you send that message? The data is also there. Ah, right, okay, understand, Amber. No, Amber. Why should I? Network is good enough. Probably there might be, let's say, random lagging in the middle. What do you call I wasn't speaking, man. How can you say lagging when I'm not speaking? Is good enough. Suppose if I like it, Aisha Zamir, basically that's use of Zamir, right? This is the server location, man, not my location. Literally everyone knows my address, man. Okay. So yeah, when you go to the answers given here, when you go to the answers given here, when you take what you call the gazettes and circulars, embassy and visa facilities, passport facilities, and stock market information. Okay. Stock market is basically information relevant for businesses. So I'll mark that as G2B. And then embassy and visa facilities. So regarding Sri Lankan embassy and regarding Sri Lankan visa facilities, like how to apply for Sri Lankan visa, those are not relevant for Sri Lankans. Those are mainly relevant for foreigners. So therefore, I'll mark that as G to G. Because when you say G to G, we are referring to government to other governments, okay, like for foreigners. So therefore, that's relevant here. In terms of passport facilities, that can be relevant to Sri Lankans, okay, I mean for the citizens here. So we can get details on how to apply for passport, all those stuffs. And gazettes and circulars, those are relevant for government employees. So gazettes and circulars are like mainly notices from the government. So those notices are more relevant for the government employees on certain rules or certain changes they have in the system. So that's relevant for the government employees. So when you say G to E, it's not all the employees. So government to employee means we are referring to government employees, people who are working in government schools or government hospitals, those kind of people. So if you mark them correct, the answers are going to be 1B and then 2D and then 3A and then 4C. So those who did this question, you all can mark your answers as well. If you all did the question, those who did not do the question, you all can even do with me. There is no issues. Actually, how many of you all tried to do the question paper before the class? Raise your hand in Zoom. Let's see. What is G to C? Government to citizens. G to B stands for government to businesses. All right, some of you have done. Okay, those who are done, you can mark your answers. So at last, we can check. Okay, Roman number 2. Tidin, tidin, tidin. I didn't get any paper link because I joined the group at 7:10. If you look at that same Zoom link, just below the Zoom link, I have put paper discussing. I have put a link. So if you have got the Zoom link, then definitely should have got the paper as well because both were sent together. Nothing was separately. Okay, next. A circuit has two switches A and B and a bulb Q. When either switch A or B or both switches are on, the bulb is lit. Write the Boolean expression to light the bulb. Okay. Now, this is a logic gate question. Whenever you get a logic gate question, your first thing has to be to read the paragraph and figure out two things. One thing is, what are we controlling? What are we controlling? That means, what is the result? Okay. Basically, what is the output? And apart from knowing what are we controlling, the second thing you should know is what are the inputs. That is, in order to what you call decide the output, what are the things you're going to go and collect the data from, right? Now, when you look at this question here, tell me, okay, if you go to the question, you can see we are here controlling a bulb, no? So we are here, the bulb is the output. Tell me, in order to control the bulb, what are the inputs we have here? Read the paragraph and tell me all of you. G2E is government to government employees. Here you go, Imam. Perfect. The switch is, so the bulb is being dependent on the result from the switch A and switch B. Okay, bulb is being dependent on the result of switch A and switch B. Now, when you go through the question has mentioned here that the bulb will be on when either switch A or B or both switches are on. The bulb is lit. Okay, so that means the bulb is on in situation where either A is on or else B is on or else both are on. Okay. Now, leaving this thing aside, if you come across a situation here, in this situation, apart from the bulb, I told you we have two. inputs, right? I'm going to label those two inputs as well. So one of the input is A, switch, and one of the input is B, switch. And the output is basically the bulb. So I'll call the L as bulb below so that I have unique letters for everything. All of you stop talking random stuffs in the chat and I'll put you out of the class, okay? Okay. Sorry, the question has mentioned bulb Q. Thank you for correcting me, Tanisha. So Q is going to be the bulb, okay? So now in this situation, what happens here is there are two inputs we are collecting data. We are collecting the data from the switch A and switch B. Tell me, when you take a switch, what are the two states a switch could be? When you take a switch, what are the two possible states a switch can be present in? Perfect. Correct. Switch can be present in either on or off. Okay. So now I'm going to figure out what are the possible situations. I'm going to figure out what are the possible situations. So there could be one situation where both the bulbs are off. There could be one situation where both the bulbs are off, on. So I'm using 0 to represent off and I'm using 1 to represent on. Okay. So there could be one situation where both the bulbs are off. There could be another situation where both the bulbs are on. Or there could be one situation where only B is on, where only A is on. Okay. The question says the bulb will be on when either switch A or B is either switch A or B, or else both switches. On that term, based on the second point, tell me, will the bulb be on? Based on the first situation, will the bulb be on? No, because check is either A or B on. Is either A or B on? No. Or else both on? No. If you go for the second situation, will yes. If you go for the third situation, will it be on? Because you're going to go and check is either switch on? Yes. If both the switches are on, then the bulb be on again. So out of the basic gates we have learned, out of AND gate, OR gate, NOT gate, what is the gate that gives the idea output is true? Or if any other input is 1, output is 1? Perfect. This truth table gives an idea of the OR gate. Okay. So you're writing the Boolean expression. You always start the Boolean expression with the output because output is Q. So we can say Q equals, and then we can mention the input. So what are the inputs we have here? A and B. So I write A and B with a small space. In between the space, I use a symbol to represent the gate. So what is the symbol we use in Boolean expression to represent OR gate? Perfect. To represent OR gate, we use a plus symbol. So answer is going to be something like this. Okay. So if you mention Q equals A plus B, you're going to get it correct. 1 mark there. Those who have any doubts, drop in the main chat. Next. What will be the state light lit or off of the bulb when switch A off and switch B is on? Okay, when switch A is off and switch B is on, what will be the situation of the light? The question is saying when switch A is off and switch B is on. Switch A is off and switch B is on. This is the situation they're talking about. In this situation, what will be the state of the light? Perfect. it will be light. Okay. So you can mention the answer is light, it will light up, or else you can also mention it will be on as well. OR gate. Because OR gate works in such that all the inputs has to be true for the output to be true. So I'll write it here, okay? We take AND gate and OR gate. AND gate works in the idea that all the input has to be 1 for the output to be 1. Okay, AND gate will work in such that all the input has to be 1 for the output to be 1. Only in this situation, AND gate will be 1. But if you take OR gate works in such that if any of the input, or else if either one of the input is 1, if any of the input is 1, or if either one of the input is 1, then the output will be 1. Okay. So depending on this only we decide whether it's AND gate or OR gate. Now in this situation, you can see when any of the input is 1, output is 1. Therefore, it's a OR gate. Is that clear, Tanisha? Can Q come on the other side? Normally we mention Q in the left hand side, so stick with this. Mention the other side is not a problem, but stick with this. Okay. So answer for the question B is yes, the bulb is turned on. Right? You can write that in your own words. As long as if you just mention on also, you get answer, right? The bulb is on. So if you mention the answer as on there, you will get 1 mark there. Next. Consider the following logic circuit diagram. Write the Boolean expression for the output X. Okay. Normally, when they give you a diagram and when they ask the output Boolean expression, what you do is always start from the left side top and then gradually go one after the other. Okay. Now you can see after the word call, so the input call A, it's going through a specific gate here, right? Tell me what is the name of this gate we have used here? How do you call this gate? Perfect. Exactly. We call this gate as the not gate, correct. We call this gate as a not gate. So normally when the input goes to the not gate, what will happen is it will become the inverse of it. Inverse means opposite of it. So you can represent the inverse of A in two ways. You can represent inverse of A like this, or else you can also represent it like this. Both are acceptable. Is Q dash a plus, is Q A plus B truth table or Boolean expression? Q equals A plus B, that's a Boolean expression. Truth table is this table which I drew here. That's a Boolean expression. Q equals 1. Yeah, Rihan. Okay, so keep in mind when an input goes to the NOT gate, the result of that is mentioned as A dash. Okay, so we have the input here as A dash. And if you look at B here, B is coming as it is as the input for the AND gate. So the AND gate, no. Tell me in Boolean expression, AND gate is represented using which symbol? No, the AND gate, no. So AND gate is represented using what symbol? Perfect. AND gate is represented using the dot. So what happens here is when A dash and B goes to the AND gate, the result of the AND gate, how you take the result is first of all, you see what is the input. What is the input we have here? One of the input we have is A dash. Other input we have is B. In between the inputs, we represent the symbol. So the symbol used to represent the AND gate is a dot. So it's going to be A dash dot B. So A dash dot B is traveling here. Now, if you look at this part here, B is going through the NOT gate. And once B goes through the NOT gate, B will become B dash. Okay. C is directly coming here. And look at this gate that looks like a crescent and tell me what is the name of this gate? Perfect. We call this gate as the OR gate. So what is the symbol we use in Boolean expression to represent the OR gate? Now here for the OR gate, the inputs are B dash and C. No. So what is the symbol I have to use to represent OR gate? Correct. To represent OR gate, we use a plus symbol. So the result of this OR gate is going to be B dash plus C. Okay. So these three are basically the basic logic gates. The gate I have used here, it looks a bit different. You can see there is a AND gate with a small circle in front. So normally when you have the AND gate with a small circle in front, we call this as a NAND gate. And if you have an OR gate with a circle in front, we call that as a NOR gate. So if you have an OR gate like this with a circle front, we call this NOR gate. So NAND gate is representing the opposite of AND gate. And NOR gate is representing the opposite of OR gate. Okay. So how the Boolean expression for NAND gate will be, first of all, you have to figure out the AND gate's response. Now for the AND gate, if you take, what is the input from the top? The input from the top is A dash plus B. Okay. I'll directly write here, okay, because X equals no. I'll write it here. The input from the top is basically A dash plus B. The input from the bottom is first of all B dash plus C. Normally, when you get a question, if you want to find the output, first of all, I told you write the input with a small space. If you notice in all these previous steps as well, I wrote the input with a small space. Okay. And keep in your mind, if your input has multiple characters, that means letter A is one character, letter B is one character. So if your input has multiple characters, add the brackets for it. Okay. If your input has multiple characters, add a bracket for it. Now what you do is you represent the symbol to represent the respective gate. I told you NAND gate is representing the opposite of AND gate. No. So when you say opposite of AND gate, when you break the NAND gate, inside the NAND gate, there are two gates hiding. The two gates hiding are AND gate and the NOT gate. Both of these gates are inside the NAND gate. That's why we say opposite of AND gate. AND gate and NOT gate is used to represent opposite. So what you should do is, first of all, you have to mention the AND gate. How do you mention the AND gate? In between the inputs, you represent a dot. And how do you mention the NOT gate? For the whole input, you add a dash. So to represent NAND gate, we put whole dot and a whole thing dash. Okay. So the Boolean expression is going to be X equals A dash dot B dot B dash plus C. Whole thing dash. Is that clear, all of you? If you have any questions, drop in the chat. Okay, perfect. Next question they have said, construct the truth table for the above circuit. If you have any questions, ask me your questions directly. Okay, I don't want indirect questions. Be specific with your questions. It's called bar as well, right? Yes, some people call it bar as well, but you can call it dash. That's your wish. You don't get a question asking how do you read this here. They don't give you all questions. So don't worry about that. Okay. Next. So what does bar do? Just like how dot plus represents and dot represents, just like plus represents OR gate, dot represents the, what do you call, AND gate, bar represents NOT gate. It's just a symbol used to represent what gate is used. Is a long line important? Yes, it is important. What does NOR gate do? Opposite of OR gate. So just like you have, it's like the combination of OR gate and NOT gate. For NAND gate, we should put long line and the dot. Yes. OR gate same, plus and the long line. If it was OR gate, plus and the long line. If we used to do the sum correctly and if we miss it, if we do the sum correctly and if we miss it correct, because it's just a 1 mark question. So if you miss it, then you lose at 1 mark. Okay. Which those who are explaining me, repeat the whole question again. For your information, I was teaching this for the last 5 minutes, I guess. So if you want me to repeat the whole 5 minutes, if you are no, the people who I replied are the people who ask me specific questions. So if you ask me specific questions, I'll reply because we all know we have only 2.5 hours. So if you ask me specific questions, then yes, I will answer your questions. If you directly come and tell, I didn't understand, I don't know, explain the whole thing, then go fly a kite. Okay, because again, there are here hundreds of people. So I had to, what do you call, cater all of them. And I have a limited amount of time as well. So please keep your questions very specific. Very specific. That's what I'm saying. For the third question, A part, I spent for the last 5 minutes there. Tell me which part you didn't understand. Okay, because I went step by step. I asked, did you understand how I got this? I asked, did you understand how I got this? I asked, did you understand how I got this? How I got this? How I got this? How I got this? Step by step I went. And at last only I got this. So if you wait to ask your question about the first fellow here, then go fly a kite. Simple. So I'm saying ask your questions respectively and very specifically. Yes, Sadhika. Yeah, sorry. Construct the truth table for the above logic circuit. Okay. Normally, a truth table is used to represent what are the different situations we can come across. And for each question, how will a circuit or how will the circuit respond? That's what a truth table is used to. Okay. Now, in this situation, you go through the whole circuit and tell me what are the inputs you all can notice, or what are the inputs we are collecting data from. Always keep in mind, inputs are mostly a sensor or a switch. Huh? So look at the whole diagram and tell me from whom are we collecting data? What are the input letters you all can notice here? Rizlan's only usually tells us to ask questions specifically. Now you also copied from him now. No, I am normally in class. You can ask any amount of questions. There is no issues. But the seminar, we have only 2.5 hours. If you don't mind me in dragging this 4 hours, I don't care. I can do it. Shall I make it 4 hours? I can give any questions you want. By the way, at the end of the seminar, you can ask any amount of questions. Huh? Like once the seminar is over, like 2.5 hours is over, you'll have unlimited amount of time to ask questions. If you're wondering what is the longest time I have done it, I have done a seminar until 4, like completed the content by 10:30 and I have done doubt clearance until 4 a.m. So if you're wondering, am I a person who will answer questions? Yes, I will answer questions. But then you all have to cooperate as well. Exactly. Okay. So if you look at this situation, the inputs we have are only three. One is A, one is B, and one is C. So when drawing the truth table, what we do is for every input we have, we're going to draw one column. Okay. So A one column, B one column, and C one column. Now, after you mention one column each for every input, for every output also you use one column, right? Now, every gate, yes, Amra, every gate has an output. For example, if I look at the first NOT gate we have here, the first NOT gates, the result of that is going to be A dash. Okay, the result of the NOT gate is A dash. Then if I look at this second NOT gate we have here, the result of this NOT gate is actually B dash. So I'm going to represent that here. And then I have an AND gate here. So the result of that AND gate is A dash plus A dash dot B. So I'm going to represent that as another column. Then the result of this OR gate we have here is B dash plus C. So I'm going to represent that as well. Okay. And finally, you can see the end of this NAND gate. Okay. For the NAND gate, the input from the top is A dash plus A dash dot B. The input from the bottom is B dash plus C. And the output of that is A dash, yes, Azar, A dash plus A dash dot B dot B dash plus C. Whole thing dash. Okay. So let's go step by step. For the people who are wondering how this NAND gate is created, we have the NAND gate like this now. So this NAND gate is created. If I take A and B as input here, the NAND gate's result will always be, first of all, you mention the input, A dot B whole thing dash. That's how the result of a NAND gate would be. Behind this NAND gate, you see, I told you earlier there are two gates hiding. I said behind the NAND gate, there are two gates hiding, right? What are the two gates hiding, I told you? Perfect. I told the two gates hiding behind the NAND gate is the AND gate and the NOT gate. So if you're wondering how it's actually present, it's present something like this. We have the A and B going through the AND gate, and the result of this AND gate will go through the NOT gate. That is how, when you take A and B, let's say, as an input for the NAND gate, the result of the AND gate is going to be A dot B. Okay, the result of the AND gate is A dot B, right? And how does NOT gate work? NOT gate will take the input and inverse it. So what is the input we have? Input is A dot B. Okay, the input for the NOT gate is A dot B. And NOT gate, what it will do is it will add a dash for the input. So this whole thing is input, no? So for the whole thing, it will add a dash. That is why we have something called whole thing dash. NOT gate, it will take the whole input, whatever input that's coming, for the whole input, it will add a dash. Okay. Next. Now, if you notice this, behind this A dot B, whole thing dash, if you notice, we can break it to two steps. We can break it to A dot B and A dot B whole thing dash. So I'm going to do that here as well to make things more convenient without writing everything at once. I'm going to break the NAND gate into two steps. One is the AND gate step and when one is a NOT gate step. Okay, so what I have done here is I have broken the NAND gate to two steps. One is the AND gate step and one is a NAND gate step. So without write, it's like, for example, without directly mentioning A dot B whole thing dash, I'm taking A dot B separately and A dot B whole thing dash separately. Okay, that's why I have these columns. So you're drawing the what you call logic gates. For every input have one column and for every output have another column as well. That's how you draw the columns. Is that clear? Okay, next. Now our next task is, why do they give logic gates question part 2 in all exam? Because my teacher said that they won't give. For your information, if there's something in the syllabus, they can give that question wherever they want. If they want, they can put a programming question in MCQ, they can put a program first question, second question, third question. That is their wish. Your teacher can't decide where will the question come. It's the person who's making the paper. A couple of months, years back, they were like, don't, this lesson won't come for the exam, this lesson won't come for the exam. Because some people, they, and idiots like you're also going to fall to those dreams. At the end of something in the syllabus is a purpose. You'll have what you call the 8 lessons in grade 10, so 10 lessons in and 6 lessons in grade 11. If you have 15 lessons, there's a purpose for the 15 lessons. If there's a lesson that's not going to be tested in the exam, then they remove that lesson from your own syllabus. So if there is a lesson, then there is a purpose. So study it. That's because Amrin, we learned only the basic logic gates in today's class. We didn't learn combination logic gates. I told you there's a category called combination logic gates. So these NAND gate and NOR gate comes under combination, which we still did not start. Got it? If we separate the expression AND gate and NOT gate, will we still get marks? Yeah. Because they don't, I'll again tell you, even in your exams, the columns needed are only the input columns and then the final output. Only these columns are actually needed. The middle, none of these columns are needed. But the reason we write all these columns in the middle is to make our work comparatively more accurate, because there are chances we can go wrong. So to make sure that we are 100% perfect, only we have the middle columns. But the expected columns are the first three input columns and the final output. Only that is expected. Is that clear, Shada? Okay. Now, you can, once you figure out the columns, the second step we have is to figure out the number of rows we have. So there is an equation how you can figure out the number of rows. Number of rows in a truth table, every row will represent a different situation. Huh? Every row represents a situation. So you can derive the number of rows. Number of rows is equal to 2 to the power number of inputs. Now look at the question we have here on Roman number 3 and tell me, in that circuit, how many inputs do we have? Zaina, to make our work easy when you're finding the final answer. You'll notice in a while, wait. It is completely fine, Mariam. Not exactly alpha. It's the limited amount of time. Correct. We have three inputs. 8 is wrong. We have three inputs. So if we have three inputs, then how many possible combinations we can have? Perfect. Using three inputs, we can have 2 to the power 3 combinations. So what is the value of 2 to the power 3? That's 8. So once you figure out how many combinations we can have, which means how many rows we can have, now what you can do is you can simplify the table by adding the rows. Okay. You can draw the table with the rows. So I'll add 8 rows here. So 1, 2, 1, 2, 3, 4, 5, 6, 7, one more. Okay. My table is not very neat. When you are drawing for exams, make sure you use a rule and draw it properly. Okay. Yeah. So there's a pattern in filling the table. When you're filling the table, first of all, go to your right side corner input. So my inputs are A, B, C. In my right side corner, I have C. I fill that input in the pattern of 0, 1, 0, 1. Can I just go in that pattern? Last row. So I just go in the pattern of 0, 1, 0, 1. Can I go? Then I go for the next input. Here I use single values now. So double of 1 is 2. So 2 zeros, zeros, 2 ones. Then I go for the next column and double it. So double of 1 is 2. Tell me what is double of 2? Perfect. Double of 2 is 4. So we fill this column in the pattern of 4 zeros, 4 ones. Okay. So if there was another input, then that will be double of that 8 zeros, 8 ones. That's how these inputs are filled. So third step is where you fill all these inputs. After you fill these inputs, you start filling the outputs based on the inputs we have. Okay. When you say A dash is the opposite of A. Okay. When you say A, that's how you fill. That's a. If you don't want to do that, you can go manually and do it. That's a shortcut to do it. If you don't want to do it, you manually go and do it. Manually, how you should do is you'll be like, okay, what are the possible situations with three switches? One situation where all three switches are off. One situation where all three switches are on. One situation where only C is on, only B is on, only A is on. One is where B and C is on. One is only A and C is on. One is only B, A and B is on. Kila. Manually, you have to go and think, which will waste your time. If you're jobless, you can manually think and write what are the three possible situations we can have with three switches. If you're jobless, you can do that. There is no issues. I just gave a way to save your time. If you don't want to save your time, waste your time. Simple. No issues. So A dash is opposite of A. So whenever A is 0, opposite of A is going to be 1. So A is 0, A dash is 1. A is 0, A dash is 1. A is 0, A dash is 1. If A is 1, A dash is 0. 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 It's just the opposite, opposite, opposite. Okay. B dash means opposite of. If B is 0, B dash is 1. If B is 1, B dash is 0. If B is 1, B dash is 0. If B is 0, B dash is 1. If B is 0, B dash is 1. Here if it's 1, here it's 0. Here if it's 1, here if it's 0. So we just write the opposite of the B column. Okay. Next we have A dash dot B. So when you say A dash dot B, we are going to compare this A dash column and the B column. Okay. We're going to compare the A dash column and the B column. So we're going to compare the A dash column and the B column using the dot. Tell me, dot represents which gate? When we are using dot, we are using dot to represent which gate? Perfect. We use dot to represent AND gate. AND gate has a logic of checking if all the inputs are true. Okay. So for this AND gate I have mentioned here, the inputs we have what? A dash is one input, B is one input. So we're going to compare the A dash and B using, we're going to compare this column and this column. These are the two inputs. Okay. We're going to compare these two columns with the AND gates logic. So how the AND gates logic work is AND gate goes and checks are all the input one. I think I wrote here somewhere, no? Okay, right here. So keep in mind, AND gate goes and checks, are all the input 1? This is how the AND gate works. So let's go one by one. Okay, again, we're going to compare only the highlighted rows. So compare the first row and tell me, when you use the AND gates logic, are all the inputs 1? Yes or no? Again, only the highlighted rows. No. So no is represented. The second row and tell me, based on the second row, are all the inputs 1? Basically, A dash and B. Are both of them 1? No. Look at the third row and tell me, are all the inputs 1? Again, we are comparing only the highlighted columns. Correct. When you compare the highlighted columns, you can see A dash and B. We are going to compare only A dash and B. Yeah? So when you compare, see, AND gate is used in between A dash and B. So we are going to compare only these two. Are both of them 1? Yes. Again, look at the fourth row and tell me, when you compare A dash and B, are both of them 1? Again, yes. So likewise, using that logic, tell me, what do you think the result of this next row will be? Perfect. The result of this row is going to be 0. What will be the result of the next row after that? Perfect. Again, we have 0. The row after that? Perfect. This is also 0. And the last row? That also is going to be 0. Because what we are doing here is we are comparing only A dash column and B column. Okay, A dash and B based the highlighted columns using the AND gates logic. So that's how it's going to work. Now we go for the next column. The next column is B dash plus C. So when you say B dash plus C, we are going to compare the B dash column, that is this column, and the C is to using the plus. Tell me, plus represents which gate? No, Tanisha. Perfect. Plus represents the OR gate. So OR gate works in logic where we go and check is any of the input 1 or is either one of the input 1. That's how the OR gate works. Okay. So depending on that, again compare the yellow color highlighted columns, the B dash column and the C column. So look at the first row and tell me, is either one of our inputs 1? Yes. Look at the second row and tell me, is either one of the inputs 1? Again, yes. Look at the third row and tell me, is either one of the inputs 1? No. Look at the fourth row, is either one of the inputs 1? Yes. So likewise, if you're going to fill, this is also going to be 1, this is also going to be 1, this is going to be 0, and this is going to be 1. That's going to be the result of the B dash plus C column. Okay, now we're done with that as well. Now we move for the next column. In the next column, we have A dash dot B plus C. So that means A dash dot B, that's representing this column. This is representing A dash dot B. And we have B dash plus C, that is representing this column. So we are going to compare these two columns using the dot. Again, dot represents the AND gate. So we have the dot between the two inputs. So that represents AND gate. AND gate goes and checks, are all the inputs 1? No. So again, compare the two inputs and tell me, when you compare the two highlighted inputs, what's going to be the result of the first row if we use a AND gates logic? Perfect. When you use AND gates logic, AND gate will go and check, are all the inputs 1? Here we have 0, here we have 1. Are all the inputs 1? No. The second row, again, if you go and check, are all the inputs 1? No. Similarly, the third row, are all the inputs 1? Again, no. Tell me what is going to be the result of the fourth row? Perfect. The fourth row, when you go and check, are all the inputs 1? Then yes, the answer is 1. Because 1 and 1, 1. So similarly, if you check the remaining rows as well, are all the inputs 1? the result is going to be no. Okay. So only in this row, you can see both the inputs are 1. Okay. That's the result of the AND gate. Now, if you go for the next gate, you can see, next column, you can see, in next column, we have the same thing we have here, only we have here as well, but the only difference is for this input, we have a dash. Okay. So that means in this column, what we are doing here is we are representing the opposite of this. Okay. In this column, we represent the opposite of this. In AND gate, we get only one output as 1, right? No. We have to always see the inputs. Our output is always depending on the input. Depending on the input, the output value can change. The idea is that the inputs, when you're comparing inputs, if all your inputs are 1, output is 1. That's how you decide how AND gate works. You can't always tell exactly it'll definitely be 1, it'll definitely be 0. It always depends on the question. Because, for example, look at this particular A dash dot B and B dash dot C column. In those two columns, when we were comparing, the data inputs we compared were different. That is why we got here multiple ones. So here, this is what? Here, another one. So we got 2 ones there. So it all depends on the question. Is that clear, Nuska? So there is no hard and fast rule that it's definitely only 1. It depends on the input. Okay, the last column, if you see, you can see the same thing one before the last column we have here as well, but only difference is a dash is added to represent the inverse of it, or to represent not gate is used. Okay, so when you see opposite of that, here if it's 0, here it should be 1. Second row, here if it's 0, here it should be 1. Here if it's 0, here it should be 1. Here if it's 1, here it should be 0. Here if it's 0, here it should be 1. Here if it's 0, here it should be 1. Here if it's 0, here it should be 1. And here if it's 0, here it should be 1. So this is how the table has to be. So now if you notice here, rather than directly coming for the NAND gate, coming for the AND gate and then doing the NOT gate. And then NOT is more easy than directly coming for the NOT gate. So whenever you get this NAND gate question, without directly mentioning one column for NAND gate, better if you can separate the NAND gate as AND gate 1 column and NOT gate 1 column without putting them directly. Okay, like for it, without putting as A, B, and A dot B whole thing dash, without doing like this, segregate as A, B, A dot B, and then A dot B whole thing dash. This will make your work comparatively easy. How do you do directly? In the mind. You do think in your mind, okay, if it's AND gate, what is the result? And when you're writing, write the opposite. If it's AND gate, what is the result? And write the opposite. So that's unwanted pressure. But if you don't put them as separate columns, you will get marks. Like I told you earlier, when they are marking your answers, they don't care about the what do you call middle columns. Their only focus will be the first 3 columns and your final column. That means in your exam paper, you're required only to mention the input columns and the final output. This is the columns that are required, the green color highlight columns, all the inputs and the final output. These are the only column that's required. All the columns we write for our advantage. Got it? Okay. So if you drew the truth table correctly, the sad reality is for this, you're going to get only 1 mark. 2 minutes. Exactly. It's an emotional damage. But if you're used to doing these questions, you can do this very fast. Okay. It's that reality. But again, if you're used to doing these questions, once you get the hang of it, it will be jujube. It'll take a bit time, but yeah. It depends on where the question comes. If it comes in the part 2 first question, then 2 marks. But if it comes for a part 2, like a main question, you'll get around 3, 4, 5 marks. Depends on the question. Okay, next. Draw the star topology with 5 computers and write one advantage and one disadvantage of this topology. Okay. When you compare star topology with the remaining topologies, the main idea of star topology is that in star topology, we use a specific device. What is that additional device we use? I feel you, Haran. Perfect. The main device we use even a 10 p.m. Yeah, yeah, fun. We'll come for that. Don't worry. No limit, Arjun bhai. Okay. So in terms of what you call drawing the star topology, the main idea of the main feature of what star topology has is it has a device known as the switch or as the hub. Okay. So that's going to work like this. So let's say you have one device here. So the question said five computers. So I'm going to mention one, two, three, four, five. You can draw the five computers in your five different ways. That's your wish. The idea is that you just have to draw five computers. Okay. So five computers and what do you call star topology? No. To represent a star topology, we need to have a switch or hub. So you can draw it in any shape you want, but you always label and mention what is it. So I'm going to mention it. This can be either a switch or a hub. Anything is acceptable. So what's special about star topology is all the devices are centrally connected to a switch or hub. Okay. So this is how the star topology is. So if you drew this, you get the marks. And apart from drawing the star topology, in that question, they had one more thing extra. They ask you to mention the one advantage and one disadvantage as well. Okay. In terms of disadvantage, you can mention if the switch or hub fails, the whole network can get interrupted. So that you can mention if switch or hub fails, the whole network gets interrupted. So this is the advantage that you can mention. So this is a disadvantage you can mention. Tell me advantage we have in the start topology. That is advantage. Actually, the opposite of this is the advantage. What is the advantage? Data information, the network can be secure, therefore security can be ensured. Nope, 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 nope. What is the advantage we have in startup? It's the opposite of what I wrote here technically. Nope, all computers can be linked. No. I told you if someone breaks, it will not, it will get affected. You can also mention something. If someone breaks, it will not get affected. What is it? Using only one switch or hub, we can connect the several computers. Now that's an advantage. The advantage we have is the failure of one device doesn't affect the network. Okay. The advantage we can tell in startup is the failure of one computer. If one computer breaks, it will not affect the network. The failure of one computer doesn't affect the network. So what I mean by that is, let's say I have labeled these computers as A, B, C, D, and E. Tell me if the computer E breaks, will it affect the communication between A, B, and C and D? Same with bus as well, Raya. Yeah. In bus, what happens is the failure of the main cable will affect the network. But in ring topology, if a device break, it will affect the network. So likewise, we can have easy to share. No, you can't mention those because other topology also it's easy to share. You can't, mentioning that advantage, you have to mention the advantage that sometimes you might not find in another topology. It doesn't have to be all topologies, but you might not find in another topology. Yes, correct. Initially. Okay. So these are advantage you can mention. If you mention advantage, like you can share files easily. Those basics Baba stuffs, you don't get marks. Okay, because you are telling the advantage, you have to tell it in comparison with the other topologies we have. Then only you'll be getting marks. Yes. So for telling one advantage, you get half marks. To get one disadvantage, you get half marks. For the diagram, you get 1 mark. This is how the marks are distributed. Correct. Please keep that. You mean screenshot gun? Done. Okay. Perfect. Next. Atika, you want this page? Done. I'll be anyway sharing this PDF at the end of the seminar. I mean, you can get it from there. This filled PDF I'll be sharing. Okay, next. Match the ports in column A with column B. Okay. So you can see they have given here a couple of ports, PS2 ports, parallel port, RJ45, and the HDMI, and they have asked how many are actually, they have asked to match it. Tell me out of the devices we have here, if you take the printer can be connected to which device? Let's see, Hafsa. Most probably no, but let's see. What is the port we use for the printer? Actually, olden days printer, based on the given answers. Correct. You can connect the olden days printers using the PS2 port. So printer and PS2 port, sorry, parallel port, you can connect it. In terms of monitor, so based on the given answers, we have 4 new monitors. If you take new monitors, through which port can we connect them? Yeah, we can connect the new monitors using HDMI port. But if I have an old monitor, so olden days monitors used something called as the VGA port. Okay. Next, keyboard. Olden days keyboard, they use PS2. Apart from keyboard, even olden days mouse also used PS2 port. In terms of Ethernet cable is internet cables, the cables we use to connect that for the Wi-Fi router all. So those use RJ45 port. Okay, so if you got these correct, that is 1C, 2A, 3D, 4B, put half marks each. If you have any questions, drop the chat. We're going for the next one now. Indicate whether the following statements are true or false about word processing software. Okay. So word processing software is a type of software we use to create text documents mostly. Okay. Like for example, those your tudes which I give you all, the papers, exam papers you all get, all those storybooks you all write by, all these books which I have text mostly are created using or they are typed using a type of software called a word processing. To take photos, we have camera application. To view our photos, you have gallery application. Word processing software is a category of applications. Okay. Now, when you take what you call the following answers, presenting of a data using tables. Yes, you can present data in the form of tables in a word processing software. Adding color to a page. Yes, you can add a color to a page. Analyze a sample of data using a line chart. in terms of generating charts, we don't generate charts on word processing software. To generate charts, we have a type of software called a spreadsheet. Perhaps or no? I will not be doing the spreadsheet question today, most probably, except that the remaining I'll try to do. Okay. So yeah, spreadsheets you can only normally use to represent charts. So that is wrong. Creating personalized letters for a large number of recipients. This is also correct. Now, we have not done this lesson in our class yet, but if you have done this lesson in our school, you all must have heard a topic called mail merge. So to create these personal letters and all, the feature that we use is called mail merge. Okay. Anyways, you don't have to know much about that now. But yeah, so if you got the answers correct like this, correct, correct, wrong, correct, put half marks each. That's a different person, Arvind. If you have any questions, drop in the chat. Huh? Match the shortcut keys in column A with their functions in column B according to the word processing software. And also, guys, I don't like your replying for other people's chat. People are asking doubts from me. So I will reply. You all don't have to take my job. Okay? Because next time if I say I'll not even tell, I'll just put you out of the class. Simple. Yeah, I'll be sharing the PDF after class. Match short keys in column A with their function in column B. Now, if you go through the answers given here, not every week, Nashisha, randomly I will. So Control C is a shortcut we use to copy files. This is not only used in word processing software, this is also used in multiple other softwares as well. In general, majority of the programs, it works like that. Okay. And then Control plus V is used to paste. Control plus Z is used to undo. Undo means go back, like, go to the previous action. So let's say you did something and whatever you did, let's say you want to remove it back, you can do the undo tool. You can use undo tool and you can go back to your previous situation. Okay. And to create a hyperlink, hyperlinks are those links. Like, for example, you might notice in those documents or something, when you go and click on certain text, okay, when you go and click on certain text, it might take you to another page. That's what we call as hyperlinks. Like, for example, if you take a website, I'll just take an example website. Let's take Master Online here. Now, when you take the master online, you can see the text, the classes, FAQ, my schedules, these are text. When you click on this text, you're taken to another page, right? So these are all called hyperlinks, right? So when you're creating a text document as well, you can insert hyperlinks. To insert those hyperlinks only, we have Control plus K. So if you got these as your answers, again, put half marks each. The total, 2 marks there. Good. If you have any questions, drop in the chat. Next, Roman number 8. Convert the binary number blah 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 into decimal. Okay, so I'll rewrite the whole number 1010. Number given there is 101010. Okay, normally from any number system, okay, this is rules, it's general. Normally, when you're going to convert from any number system to decimal number system, okay, when you're going to convert a number from any random number system to decimal number system, the method is actually kind of similar. So how the method works is you have to multiply each digit by its place value. Multiply each digit by its place value. Which means, for example, if I have a number like this, let's say a decimal number called 231. If I have a decimal number called 231, to get the place value, first of all, I have to mention the base. Now, if 231 is a decimal number, the base is going to be 10, no? So I'm going to first of all write 10. And after I write the base, second is a position. Always position starts with 0 and keeps on increasing. Okay. So in this situation, the 10 is representing the base of the number. and 0 is representing the position. Always position starts with 0. Now, if I derive the value of 10 to the power 0, 10 to the power 0 is 1, 10 to the power 1 is 10, and 10 to the power 2 is 100. And that is why when you take a decimal number, in decimal number, we call this as ones place. See, because the value is 1. The reason we call this tens place is because the value is 10. And the reason we call hundreds place is because the place value of that is 100. So these ones place, tens place, hundreds place, these all represents the place value. So place value can be derived by using the base of that number to the power position. Okay. Now, if you look at the given answer here, which is 10 blah blah blah, this is a binary number. So in order to get the binary's place value, we are going to use the base as 2. So 101010. So to get the place value, first of all, I'm going to use the base as 2 to the power 0. Then 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7. That's basically 1, 2, 4, 8, 16, 32, 64, 1, 2, 8. Okay. So once you find the place value, the next step is actually multiply each digit by its place value. So when you multiply each digit by its place value, 128 times 1 is 128, 64 times 0 is 0, 32 times 1 is 32, 16 times 0 is 0, 8 times 1 is 8, 4 times 0 is 0, 2 times 1 is 2, 1 times 0 is 0. So I multiplied each digit by its place value. And now what you do is you just add them together. So I'm going to ignore the zeros and add only the other numbers. So once I do it, 128, 129, 130, 130, 160, 170. So answer is going to be 170. So you can mention the answer as 170 or else 170 based in both are acceptable. Just 170 is also completely fine. So this is the answer for 10101010 in decimal. Is that clear of you? Just write the place value and multiply each digit by its place value and find the sum of them together. Okay. That's the answer for Roman number 8. Again, you can omit certain steps. So you don't have to write these 2 to the power blah blah blah. You can directly mention 1, 2, 4, 8 also. There's no issues. They don't check much on the steps. Convert C5 base 16 into octal. Okay. If you look at this number C5 base 16, let me write it here. Roman number 9. C5 base 16. They are asking to convert C5 base 16 octal, right? First of all, look at the number given and tell me the number given that is there in which number system. The number they have given in the question, that is a number represented in which number system. Perfect. That is a number represented in the hexadecimal number system. How we know that is by the base. So if the base is 16, that's representing a hexadecimal number system. Okay. So what I'm going to do is I'm going to convert this to octal. But we have a problem. From hexadecimal, we can't directly convert to octal. There is no direct conversion method. So because there is no direct conversion method, we have two options. We can either convert this to a binary number and convert the binary answer to octal, or else we can convert this decimal and convert the decimal answer to octal. But when you compare binary and decimal conversion, what is comparatively easy, binary or decimal? Perfect. When you compare both of them comparatively, binary conversions are easy. Okay. So first step, what we are going to do is we are going to convert C5 base 16. I'm going to convert that first of all to binary. Now, if you look at the origin of how hexadecimal number systems were created, you will know hexadecimal number system created where one digit represents 4 bits. So behind one digit, there are 4 binary digits hiding. To figure out what those 4 bits are, you can write the first 4 binary digits place value. Okay, if you want to figure out what are the 4 bits hiding behind each digit, then write the first 4 bits place value. Now, in hexadecimal, apart from using numbers, we use letters, right? A, B, C, D, E, F, killer. So what is the value of the letter C? A is 10, B is 11, and then C is perfect. C has holds the value as 12. 12. So in that situation, what happens is after you figure out that C is 12, now next step what you're going to do is you're going to figure out, okay, to form the respective value, what are the numbers we have to add? To form 5, we have to add 4 and 1. Similarly, tell me to form 12, what are the numbers we need to add here? Yes, number. Correct. 8 and 4. Below the numbers we need, write 1. Below the numbers you don't need, write 0. And now you can join them together. So hexadecimal number system was created to shorten binary. How we shorten binaries? We group 4 bits as one digit. So if you elongate that binary number, the full number would be something like this. 0, 1, 0, 1, 2, 3. Yeah. So now I have found the binary number. Now, just like how hexadecimal was a number system created a shortened binary, octal is also numbers. Octal and hexadecimal, these are two numbers that were created to shorten binary. Hexadecimal shortened in such that hexadecimal was shortened in such that 4 bits represent one digit. But octal was how many bits represent one digit? Octal was made before hex. So octal had how many? Perfect. From where did you get 1, 2, 4, 8? They are the binary first 4 bits place value. When you take a binary number, let's say we have binary number like this 0, 0, 0. What's the place value? 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. It is 1, 2, 4, 8. So these are the first 4 binary place value. First 4 bits place value. Is that clear, Mariam? Perfect. Octal is a number system to shorten binary by 3 bits by 3 bits. So these 3 bits represent one set. We always start the separation from the right side. These 3 bits represent one set. When you don't have a complete set, you can add the 0 in front. So I can separate this into 3 sets. Okay. I can separate this into 3 sets. That is 0, 1, 1, 0, 0, and 1, 0, 1. So I told you, if you take what you called hexadecimal, so octal number system, what happens there is 3 bits represent one digit now. So therefore, if you want to find what is the value these 3 bits are representing, you have two options. One option is you can use a long method like this. That is, you can take 101 behind everything, you can put 2 to the power 0, 2 to the power 1, 2 to the power 2, 1, 2, 4. Okay, multiply 4 times 1 is 4, 2 times 0 is 0, blah, 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 blah. Killer. You can do a very long method like this and get the answer as 5. Okay, the same method like we did here to convert from binary to decimal. Or there's a shortcut. The shortcut what we have is below every digit, just write 1, 2, 4, 1, 2, 4, 1, 2, 4. Okay, below every number, just write 1 to 4. So 1 to 4 are basically the first 3 bits place value. You can see in binary, first 3 bits place value is 1 to 4. Okay. And wherever 0 is there, cut the place value and write the sum of the remaining. So after I cut wherever 0 was there, I cut the place value. So these 1 to 4 are basically place values. Huh? So after I cut that, the sum of the remaining here is 4 plus 1, 5. Here nothing is remaining, so the sum of remaining is 0. Here 2 and 1 is remaining, so sum of the remaining is 2 plus 1, which is 3. So now you just join them together. The answer is 305 base 8. Okay, so octal was a number system used to shorten binary by taking 3 bits as one digit. So that's why 101 is represented by 5. So yeah, this is how it works. How did you find that C is 12? Because in hexadecimal, apart from if you are forming a hexadecimal number, to form a hexadecimal number, apart from using numbers from 0 to 9, okay, apart from using numbers from 0 to 9, we can use letters from A to F. So from those letters, A is equal to 10 and the value keeps on increasing. This is already defined. So C is 12, D is 13. So that's how we find. So the first 2-digit number gets the value as A. That's how it goes. How did you cancel them? Whenever 0 was there, I cut it off. See, wherever 0 is there, I cut it. 0 is there, cut it. 0 is there, cut it. Is that clear, Abhiha? We add 148, Tanisha. Can't you write the answer without 0 by writing 35? What is the sum of nothing? So there's like the sum of this is 0 because we are what we're doing here is technically, if you are wondering what is happening here, okay, in this stage, what is happening is I'm finding the decimal value equal for triple zero and decimal value equal for 011. That's what's happening here. So 3 bits have to represent 1 digit. So the actual method, like I told earlier, is this is the actual method you have to follow, but this is long. So to make our work easier without following that method, we are doing this. So when you convert triple zero, when you convert that from binary to decimal, the answer is going to be something like 2 to the power 0, 2 to the power 1, 2 to the power 2, which is 124. Multiply every digit by its place value, add them together, answer is 0. What do you think? So technically what we are doing here is we are converting binary to decimal there. So when you convert 3 000 to decimal, answer is 0. So we have to mention 0, Raghavi. 2 marks, Zara. Did you, if the number are 1 or 0 in second step? No, what I did is whenever number is 0, I cut the place values. When number is 0, I cut the place value and I wrote the sum of the remaining. So here 4 and 1 is remaining. So 4 plus 1 is 5. Here nothing is remaining. So answer is 0. Here 2 and 1 is remaining. So 2 plus 1 is 3. So you cut and write the remaining. In the exam, what method is good? Whatever method where you can save time. So this is the method I can save time from. And this is the method that majority of my students follow as well. So if you have a better method where you can save time, go with that. As long as the examiner knows that you found your answer by yourself without copying, they will give you marks. So you get 2 marks for finding the answer. In certain papers, they might break the finding binary as 1 mark and finding octal as 1 mark. Some papers directly for octal, they will give you 1 mark, 2 marks. Okay, some of you all said you all did the question before the class started, right? So based on the marks you all put now, tell me out of 20 marks, how many marks you all got? The people who did the question before class. 19, okay, good. 16, good. 17, 20. How you have all these things inside your brain? I feel like dizzy learning all this. That's what iterations of practice is, brain. You can't learn everything in one day and fit in the head. What you collect data, collect data, collect data, collect data, and you improve the size of your brain, man. Understandable, yeah. 19 and a half. Understand. Oh, nice thing. What else, Abad? We just now started. For your information, I am directly coming from class. When all this time I was teaching at Kolannavar, and I started the Zoom meeting actually the three will. If you all were the first 10 people to join the meeting, you all must have noticed first of all my audio and video was from the meeting while I was from the three while I was speaking. If you all are the first few people who joined the Zoom meeting, you all notice that. Okay. Anyways, let's go for the next question now. If y'all can even eat by yourself there, I mean y'all can just eat, drink. ආතලෙක ඉන්න පුළුවන්. බලන්න අපි වගේ කට්ටිය. Oh wait. How did y'all get 20 marks? The people who got 20 marks, how did y'all get 20, 19 marks? I didn't discuss question number 10 now. The maximum marks you can get is 18 marks. ඔන්න හොයලා. පච්ච පොයියා. I didn't even discuss the 10th question. And you all got 20 marks. Jai. Exactly. What is Amir? Go ahead. I can easily see all the people who copied now. I mean, like, who lied now. Good, good, good. Okay. Let's see, Fafsa. Let's see. Not copy, you're lying. Indicate true or false in the following statements regarding electronic spreadsheet software. Control plus NE combines make the last key of the worksheet as the active key, active cell. Control plus N key combination makes the last cell of the yeah. Control plus home. So in your keyboard you have control key and home key. So control and home will go for the first cell. Control and N goes for the last cell. You don't find the N key in normal keyboard. You find that N key only in the long keyboard. That keyboard which has numbers in the right side corner as well. So only those you can find that. So that's a true statement. Ah, no, sorry, that's different. Uh that's my phone's wallpaper as well. Yeah. It's literally 9-6. My literally 7. Let's see, Praveen. I just okay, that's fine, Nuska. No issues. Okay. Write in the formula D2 equals blah 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 will calculate the relevant calculation. Okay, tell me the second one. Is it correct or wrong? The people who have learned this in school. Anyways, I'm not going to teach spreadsheet today. But the people who have learned spreadsheet questions in your school, what do you think the second statement is? Is it true or false? So basically, when you take spreadsheet softwares like Microsoft Excel, Google Sheets, those spreadsheet softwares, you can write something called as a formulas. Okay. When you're writing formulas, you always start a formula with equal symbol. So you can't mention D2 equals blah blah blah. Always a formula has to start with equal symbol. So you can't have D2 in front. So if you have D2 in front, the calculation will not happen. So therefore, this is false. No need to put brackets. Brackets are needed only if it's relevant. For this situation, it is not relevant. The alignment of the numeric data entered into a cell is right aligned. So normally if you take a cell, those are wondering what is a spreadsheet, this is how a spreadsheet would look like. Okay, this is how a spreadsheet would look like. So normally if you take a spreadsheet, when you type values here, depending on what are you typing, the alignment will change. So you can categorize the values you type in a spreadsheet in two categories. Okay, yes, Excel. You can categorize them as labels and values. Whatever you type inside a cell. So each of these boxes is called a cell. Okay. Each of these box is called a cell. So whatever you type inside a cell, you can classify it into two categories. One is label and one is values. So labels represents any qualitative data and values represents any quantitative data. That means any data that can be measured is called a value. So for example, let's say inside a cell, if you go and write something like 10, 20, 10.5, or else 27%, or else let's say a date like 2nd of July 2025, or let's say 4 p.m. Okay. These all are measurable values, no? So yes, Imam. Whatever you can measure, all these measurable data, these are called as values. But if you write data that are not measurable, like for example, let's say red, green, Amal, Bimal, okay, or let's say yes, no. These are all qualitative data, like these letters, words, all those are qualitative data. So those all are considered as labels. So normally, whenever you type a label inside a spreadsheet, the labels are always left aligned. See, L is L. Always remember L is L. So labels are left aligned and values are right aligned. So for example, I do and show you, if I go and type here, for example, the word called Amal, you can see it's left aligned. But if I go and type here a number called 45.9, it's right aligned. So values are right aligned, labels are left aligned. Got it? Yeah, I'm with Amal, Bimal, Chamal. And then there is no one called Bimal. It's after Chamal who comes. Exactly. See, if you're coming to my class, after Chamal, I don't use Bimal. I use Emily. Anyways, that's the idea of labels and values. So the alignment of numeric data into a cell is right align. That's true. What about when text and numbers comes together? Can you measure? Give me an example, Nuska, and then I'll tell you. Is there any story for Amal, Bimal, and Shamal? Yeah, Rizlans has a story. If you all have learned Shyamakar and the Rizlans, he would have thought of the story. Like the month in words and the date in numbers. Like you're saying something like 10, 10th July, something like this. Okay, so there is a condition for that. If you type in normal text, okay, if you just go and type in normal text, it will consider that as a label. If I just go and type here 10th July, it will consider this as a label. Okay. But if I write it like this 10th July, okay, if I write it like this, and in spreadsheet, there's an option here called format. So from number format, if I go and change it, there's something called custom date time killer. See under format, there's an option called custom date time. From here, I can go and change that as textual data like this. So if I go and take day, remove the date, remove the day with leading zero, day without it. So month is August. Ting, 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 ting. So from this one, from what do you call date and so there's something called number format killer tool. So from number format tool, if I go and modify from it, there's an option you can select here from. So from here, if I do some modifications, now it will come for the right side. So even though it looks like the same, okay, I can even make the TH come there. Let me make the TH come there as well. The format, number, custom date time, and let's make the TH come here, will you? So I made the TH come here as well. But the reason of the alignment difference is because the first one I typed it manually. But second one, I didn't type it manually. I went and changed the number format. You can notice another difference as well. If you observe it properly, Nuska, if you look at the top part here, even though I have clicked on this cell called 10th July, here when I click on 10th July, it's showing as 10th July in here as well. But if I click on the next cell, even though you can see 10th July, if you look at this is called that formula bar, okay? This area we call as a formula bar. So if you look at the formula bar, you can see it's mentioned in a numeric way. So it depends on how you type. If you just randomly go and type it, it is considered as a label. But if you type a date and change the format from this, then it's considered as a value. So it depends on how you type it. In general, if you type it, it's considered as label. Is that clear, Nuska? Perfect. So generally it's label, unless you go and change like this. Okay, next. Fill method using fill handle tool is not suitable method to copying formula. Pause. When you're copying formulas, there are two methods. So let's say if I'm writing a formula, this is how. So I can start a formula with the equal symbol and I can mention something as equals, let's say, and I can write, let's say something like equals 10 times 5. I'll make the work easy. So if I write equals 10 times 5 here, I'll get the answer as 50. So the spreadsheet software will do the calculations on behalf of me. Now to copy formulas, there are two methods. One is Control C, Control V. So in my keyboard, I can press Control C. I can go for another cell, Control V. So Control C, Control V, you can copy formulas. Apart from that, if you look at that cell in the right side corner, there's a small circle, right? In some software it's circle, in some software it's square. So I can click on that, I can drag as well. So if I click and drag also, the formulas will get pasted. So you can copy paste formulas using Control C, Control V, that is copy, paste, or else you can copy using fill handle tool as well. So fill handle tool is this circle or dot you have in the right side corner of the cell. So that is also a correct statement. So they're saying it's not suitable, that's wrong. Anyways, is that clear all of you all? Those who did this question, you all can give half marks each. Okay, let's go for the next question. Okay, I'll discuss operating system. I'll discuss logic gate as well, and then give a small potty break. Okay, those are wondering, asking break. Focus, all of you. By the for now we have covered 20 marks. Huh? So you see, the first question is a mixed question. It's very easy. It will take a bit time. So, but 20 marks we have saved now. So you can spend around 20 minutes to finish those questions. How many minutes? Depends. Wait and see. It's a surprise. Okay, the first question. Draw the logical circuit corresponding to the Boolean expression Q equals AC dash plus A dot B whole thing dash. Okay, look at this. Now, we're not drawing the circuit. Logical circuit is a circuit diagram. We're not drawing the diagram. First of all, you should know exactly, Surya. You should first of all know what are the letters, what are the input letters used. Now, left side, we always mention output. In the right side, only we mention the input. So go through the equation, tell me what are the unique letters you can see here. To go through the right side, what are the unique letters you can notice there? Correct. The unique letters you can see are A, B, and C. So for one column, I'm going to mention A. Sorry, I'm going to mention letter A. I'm going to mention letter B, and I'm going to mention letter C. Okay. So these are the inputs we have. Now I'm going to go through this and figure out what are the gates used. If you have dash, dash represents NOT gate, plus represents OR gate. Now here we have the whole thing plus and dash. Okay. I told you a while ago that if you use plus and dash both, it represents one gate, like OR gate and not. No, plus is representing OR gate, dash is representing NOT gate. Okay, so for A and B, for both only, it's there. So in both of them are used for a specific input. Yes. Dot and dash is NAND gate. Plus and dash, that's NOR gate. Okay. So basically, A plus B is the OR gate and NOT gate used together. Okay. OR gate and NOT gate used together. Okay. Now, if you notice here, we have AC dash. In the given data, there is no any symbols. Keep in your mind, sometimes if you have something like A plus B, which is AND gate, you can represent AND gate without the dot as well as AB. Okay, so both are acceptable. If you take AND gate, both are correct. So therefore, if there is no any symbols here, that means in between these two, we have the AND gate. First of all, tell me, are you all clear on the parts of figuring out what are the inputs we have and then figuring out what these symbols represent? The gates used. Is that part clear? If you have any questions, drop in the chat. Huh? Drop your questions in the chat. Those who have any questions, drop your questions in the chat. Basically, a person who listens, his questions are always specific. The people who will be daydreaming and suddenly are ahasing kadapatunu again, they'll come and see here. They are the people like wondering what the hell happened. Killer. Because the person who is listening and they don't understand, he'll be like, sir, why is that not gate? Or why is this AND gate? Or why is this not gate? Killer. The questions are specific. The people who don't listen anything, like, so I didn't understand anything. Because that you can't tell that you didn't understand anything, right? Because technically is dash is different not gate. I told you a while ago as well. Okay. How and basically there is an indirect way of saying that it's not this is not a correct ideology, but some people have that ideology. Okay. Some people have the ideology saying that mostly AND gate gives an idea like multiplication. Because how AND gate works, AND gate always goes and checks is all the inputs one no. If any of the inputs are zero also, like for example, let's say we have four inputs. Okay. When we have four inputs, if only one of the input is zero also, output will be zero no. So for the AND gate to give you one, always all the output has to be one. So indirectly, if you see, AND gate has like a ideology of multiplication. Because if you multiply 1 times 0 times 1 times 1, okay, 1 times 0 is 0, 0 times 1 is 0, into 0 is 0. Okay. So if you look at AND gate, indirectly it has like a multiplication logic. So if you again go to your maths scenario, in maths you might notice sometimes when you have something like x into y, sometimes we might represent xy, right? In maths. So That is the story behind removing the dot because they treat AND gate like a multiplication, even though it is not multiplication actually happening. They treat it as multiplication, and that is why they take it like that. Is that clear, Kish? Yes, I know. Perfect. So now let's represent this. When you're drawing the diagram, there's an order you have to follow. So as per the order of drawing the diagrams, the order works something like this. So dot is not necessary. Dot is necessary, but some questions they'll be lazy and they might miss the dot. Is what I'm saying. When you're drawing, make sure you do the dot. Don't take unwanted risk because every mark is valuable. One mark can push you from A to B or B to C and C to S and S to fail. So every mark is valuable. Don't take risk unwantedly unless you're 100% sure that you're going to get 100 marks or 95 plus marks. Don't play with your marks. Okay. You look like, nah, not exactly. Huh? Because I was a person who used to take risk, but I never took risk in any other subjects apart from maths. Maths was the only risk. I think in my oral paper, I went and I wrote the answer as this question is wrong. Please check this question. And I told where the question is wrong and I told how the question should be correct. And if the question is correct, what should be the correct answer? I went and corrected the question itself in the question paper. I was so much araparichi because I knew that I would get full marks for the paper. Okay. But I took that risk only in maths. I never take that risk in other subjects because it's risky. Not exactly, sir. Understandable. Okay. That's life, Amrin. Okay, anyways, so when you're drawing this diagram, there's an order. Okay. The first you should draw the brackets. Whatever is there inside the brackets, that is what you should draw first. And second, you should draw whatever is there inside the NOT gate. And third, you should draw whatever is there inside the AND gate or is NAND gate. And last, only you have to draw whatever is there in the OR gate or is an OR gate. Okay. So as per the situation here, if I go for the brackets, in the bracket, we have A plus B whole thing dash. So to draw A plus B whole thing dash, I'm going to draw here the OR gate with a small circle in front. I told you OR gate with a small circle in front. That's the NOR gate. So that's how I drew the A plus B whole thing dash. Is that clear of you all? I feel you're amazing. Yeah, he'll kick you out of the class, Vishnu. If you have any questions, drop the chat. Huh? So now I'm done with the brackets. After brackets, next thing I should do is a NOT gate. So if I'm going to find the NOT gate here, NOT gate is there inside here, the C dash. To make C become C dash, I'm going to pass C through the NOT gate. So NOT gate looks like this. See how the NOT gate is. So then I'm done with this as well. So now C dash is also done. Right, Nuska? Now I have remaining AND gate and OR gate. So tell me what should I do first as per the order? Should I do the AND gate first or the OR gate first? Yes, Shazam. Correct. I should do the AND gate first. So draw the AND gate. You see, I have to have the input as A and C. See, for the AND gate, A is one input, C dash is another input. I have C dash already here present. I need to get A. So to make sure I draw a neat drawing, I'm going to pull a value from here. To make sure it doesn't clash with B, I take a small curve. So the small curve is to show that A is not connected to B. Okay. Again, I take a small curve here to show it is not connected to C. So I have A here. So the curve is to show it's not connected. So now I have A here. I have C dash here. A and C dash has to be connected through the AND gate. So AND gate is going to look something like this. So now I'm done with the AND gate as well. Okay, now I'm done with the AND gate as well. Is the order same for all question? Yes, correct. Yes, Nuska, there is. I'll share the link, okay? But you have to pay. It's not expensive, don't worry. There is no dash on top of plus, no. Here, can't you see a dash? Yeah, that's why I'm doing NOR gate. So NOR gate is plus and whole thing dash. Both together is will come in NOR gate. Yeah. Sadhana. Next. Nabiha, did I answer a question? And next we have the OR gate. Okay. In OR gate, if you look at the left side, we have AC dash. So AC dash I have here. Okay. A dot C dash I have here. Then the part called A plus B whole thing dash I have here. So the output of this NOR gate is A plus B whole thing dash. That's coming from here. A. This is A plus B whole thing dash. So both of them are going to be connected using the OR gate. So I can represent the OR gate like this. So this is basically Q. So this is how the diagram is going to be. Is that clear, all of you? So start from the left side. You first of all write all the inputs and draw in this order. Can we draw the A and C first and B after that? Again, I'm saying you this order will not affect in certain questions. Now, in this question, if you draw the A, C first and then come for the brackets, there is no issues. In certain questions, order can get messed up. So if you want to have 100% accuracy, you follow this method. If you don't want 100% accuracy, follow any method you want. So this is a 100% accuracy method. This can never go wrong, the order. But that doesn't mean that this will be applicable for all the questions. It's like, for example, when you have BODMAS. As per BODMAS, what do we do first? Division or multiplication? Hmm? As per BODMAS, what do we do first? Division or multiplication? Yeah, yeah, I will be explaining now here. Perfect. As per BODMAS, we do division first. Okay, that's a BODMAS. No, we do division first. But let's say if you have a question like this, 2 times 3 or 2 times 6 divided by 3. Okay, if you have 2 times 6 divided by 3. And if you have 6 divided by 3 into 2. Now, in this question, okay, in this question, if you do multiplication first or division first, there won't be different answer. Both answer will be same. In this question, if you do multiplication or division, both will be same answer. But in this question, if you do multiplication first, you will have different answer. If you do division first, you will have different answer. So when you're following BODMAS, if you stick with BODMAS, you will have 100% accuracy. Okay. But if you feel like, no, sir, in this question it's working, blah, 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 and dance, then in certain situation it will work, certain situation it will not work. So it always depends on, do you want 100% accuracy or do you want situational accuracy? Situational accuracy. That is like some people are there in certain situation will be work, in certain situation will not work. So situational accuracy means certain situation it will work, certain situation it will not work. That means like if you draw the left side first and right side second. Not always it will work like that. Got it? Hmm. So next question they're saying construct the truth table for this. Again, to draw the truth table, you're going to have all the inputs in one column. So A, B, C has one column, A, B, and C. And after you have one column each for every input, for every output, you have one column as well. So if you look at this NOR gate here, the output of the NOR gate is A plus B whole thing dash. Okay. And Imad, I don't have time to check that. If it's matching, it's so good to go. That's the plan today. What do you call it? I told you always you take a NOR gate and not NAND gate. It's a combinational gate. No, you're combining AND gate and so NAND gate is by combining AND gate and NOT gate. Similarly, if you take the NOR gate, the NOR gate looks like this. No, the NOR gate we have here, for example, let's say X and Y are the input for the NOR gate. Then the result is going to be X plus Y whole thing dash. No, NOR gate is formed. Okay, NOR gate is formed by writing first X and Y go to the OR gate, and the result of X and Y is going through the NOT gate. That's how the NOR gate is formed actually. It's a combination of OR gate and NOT gate used together. Because if you use OR gate first, result is X plus Y. When X plus Y goes to the NOT gate, X plus Y becomes X plus Y whole thing dash, right? Okay. So that same concept is only used here as well. In NOR gate also what happens is this X plus Y whole thing dash is obtained by first of all going through X plus Y, and that X plus Y is going through the NOT gate. Okay. So therefore, when you're drawing the truth table, you can segregate it without directly writing A plus B whole thing dash. It's better if you can separate and write A plus B separately and A plus B whole thing dash separately. Again, it is not compulsory. It is better. Okay. Which side are we supposed to write first? As in, we first of all write all the inputs. Once we write all the inputs, one column each for every output. So the next output we have is, let's say, C dash. So I'm going to mention a C dash. So this is done. This is done. The next output we have, so this is done. Next output we have is A dot C dash. So for that also I'm going to mention another column. So for every output, one column, and every input, one column. So first you mention all the input. For output, always go in this direction. Left side top to right side bottom. And then we have finally the Q, which is A plus B whole thing dash plus A dot C dash. I have added an extra bracket here. That's not important, but yeah. And the odd is also not important. You can swap and write, not a problem. Next. Here we have three inputs, right? So using the equation I told you earlier, tell me if there are three inputs, how many combinations we could have? Perfect. When there are three inputs, we can have 2 to the power 3 combination. 2 to the power 3 is equal to 8. So 1, 2, 3, 4, 5, 6, 7, 8. So you start filling from the right side corner input. So here the right side corner input is C. We go in the pattern of filling it as 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. The next input you double it. So 2 zeros, 2 ones, 2 zeros, 2 ones. Next input you double it. So double of 2 is 4. So 4 zeros and 4 ones. So this is how this is filled. And next, when you compare A plus B, you're going to compare A column and the B column using the plus logic. Plus represents the OR gate. So we're going to compare the A column with B column and C with OR gates logic. So how OR gates logic work is you're going to go and check is either one of the input one. So if I compare A and B in the first row, is either one of the inputs one? No. Second row, is either one of the inputs one? No. Third row, is either one of the inputs one? Yes. Fourth row, is either one of the inputs one? Yes. Fifth row is either one of the inputs 1. Yes. Sixth row is either one of the inputs 1. Yes. Seventh row is either one of the inputs 1. Yes. And last row is either one of the inputs 1. Yes. So here for A in the OR gate, the inputs we had was A and B. That's why it was A plus B. So I compare and see is either one of the inputs 1. So if either one of the inputs are 1, I wrote 1 or else I mentioned 0. Is this part clear up to here, all of you? Perfect. Next, what you do is you have the A plus B whole thing dash. Now, A plus B whole thing dash is the opposite of A plus B, right? So if A plus B is 0, A plus B whole thing dash is opposite of that, it should be 1. So when you have 0 here, we're going to write 1 here. When you have 1 here, we're going to write 0 here. It's the opposite of that previous column. So it's the opposite of that previous column. Okay, A plus B is here, A plus B whole thing dash is there. What do you mean by second one? In the second one, we are not seeing C. We are seeing only if you look at this, what you call the expression here, we have a plus B. So that means we are only comparing the value of A and value of B. We don't take the value of C. So when you compare only A and B, see both are 0. Is that clear? Hmm. For A plus B, how did you identify its NOR gate? Because A plus B whole thing the is NOR gate. It's like asking how do you know that dot is AND gate? That's what I taught you all. Dot is representing AND gate, plus is representing OR gate, dash is representing NOT gate, dot and whole thing dash is representing NAND gate, plus and whole thing dash is NOR gate. Got it? Hmm. Okay. Then C dash. C dash means opposite of C. So C is 0, 1, 0, 1, 0, 1, right? So opposite of 0 is 1 here. Opposite of 1 is 0 here. So C dash means opposite of C. Just look at the values of C and completely write the opposite of those values here. So completely the opposite of the values of C I have mentioned here. Next is basically A dot C whole thing dash. So A dot C dash. When you say A dot C dash, we're going to compare the A column with the C dash column. Okay, A column with the C dash column. And you can see A dot, we have C dash. And both of these columns are compared using the dot, where dot represents AND gate. And how does AND gate work? AND gate goes and checks are all the inputs 1. Okay, that means A is 1 input, C is 1 input, are both of the inputs 1. Okay, so when you compare A and C dash for the first row, are all the inputs 1? Not exactly the measure. No. So go through all the rows and tell me if I label this as, let's say, row number 1, 2, 3, 4, 5, 6, 7, 8. But of the rows you can see A as well as C dash. Both are 1 in which rows? Perfect. Only in 5 and 7 you can see both the inputs 1. Okay, only in 5 and 7 you can see both the inputs 1. So only for 5 and 7 I wrote 1. For the remaining all I wrote 0. Remaining all I wrote 0. Now, the next column. The next column, if you see, we are going to compare A plus B whole thing dash, that is this column, A plus B whole thing dash, with A dot C dash, that is this column. And both these are compared using a plus operator. So plus represents the OR gate. OR gate goes and checks is either one of the inputs 1. So compare both these highlighted columns and tell me in what are the rows you can see at least one input or either one of the inputs 1. You put 0 instead of 1. What do you mean by you put 0 instead of 1? That A Ash person. That's what I explained a while ago, man. You're talking about this thing, right? Where my mouse is at the moment. That's what I'm talking about, right? Okay. In there, what we are doing there? We are doing A plus B, right? Okay. Look at that second row and tell me in the second row, what is the value of A? What is the value of A? அதுதான் படிச்சு படிச்சு செஞ்சது. Sad life. Okay, so you compare what do you call these two columns and you compare with the OR gates logic. OR gates goes and takes any of the inputs one. In the first one, yes. Second one, yes. Third one, no. Fourth one, no. Fifth one, yes. Sixth one, no. Seventh one, yes. Eighth one, no. So any of the inputs one, again, you compare these two columns and see. You compare and see. These are the values you have to get. So if you got these correct, you can give marks here. So for this question, I guess you might get around in alarm system, blah 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 blah. Draw the logic gate for the 5 marks, 5 marks. They might give you around 4 marks here, 4 marks here, averagely, and they might give you around not 4 marks here. You might get around 2 marks here, and then 2 marks here. Or they're not given the proper distribution here, but average is to be around 3 marks and 2 marks, or 3 marks and 3 marks, something like that. For my marking, how I'll give it is I'm gonna be like half, one, 1.5, two, 2.5, three, 3.5, 4. For every row, I'll give half marks. So if every row is correct, you get 1 mark. So total you'll get half, one, 1.5, two, 2.5, three, 3.5, 4. I'll give 4 marks to the truth table. And for this circuit, I might give you around for using 1, 2, 3, 4. For using 4 gates, I'll give half marks each. So half, 1.5, 2. Around 2 marks here. For the last column, can you put as Q also? Yes, you can. I told you not to chat in the chat. Don't make me repeat this 1,000 times. I mean, reply for others' questions. Please read how I strongest results. I will check it in a while. What do you call Rehan? Because I'm doing multiple questions and I can't do that. Okay. Exactly. So, no, Surya, they are not. Okay. Is it optional to put Q color? You can label that as Q or you can label the whole thing. Both are correct. Either one of them is important. Either you mention Q or you mention this. Both are same. There's no difference. Okay, next. If there's any questions, drop in the chat. Huh? An alarm system was required to be installed in a school for security reasons. Relevant sensor should be installed at office entrance O. Okay, so there has to be a one of the sensor in the office entrance. That's O. Office entrance sensor. The computer lab entrance. So C is representing the sensor we have in the computer lab entrance. So computer lab entrance sensor. And storage room entrance. Okay, so in storage room also there was a sensor itself. So storage room entrance sensor. If someone tries to open these doors, the system should be alerted. Okay. When they say open these doors, are they asking of opening one of the doors? Or are they saying all the doors together? One or together? What's the idea you get? I'm saying all together or one of these. Ade, where is your common sense, man? Okay, the person called Ash, I'm going to put you out of the class. I literally told her if you'll go and reply under other people's chat, I'm going to literally put you out of the class. Get out. Done. You're the first person I'm putting out of the class. Huh? Don't make me do this again and again. Exactly, Surya. Yeah. And I practically think, man, I all like going to be like in a video, like a conference and make sure that Mashang open the door, open the door, open the door. Exact millisecond, all three of you open together. It's impossible. Oh, you're going to one floor open. After you open it, open the second door. After that, open third door. After that, opening three doors. Then only what do you call alarm is going to ring. So use your common sense also with it. Okay. So there are basically the alarm system is required to be installed in school. Relevant sensors should be then office entrance, computer lab entrance, and storage. So there are three places. If someone tries to open these doors, so if someone tries to open these doors, as in any of these door, if someone tries to open, alarm has to be rung. Okay. So understand the situation. Always read it, understand, and apply a common sense also with that. You can't don't just blankly try to understand the question. Apply a common sense a bit as well. So when any of these doors are open, the sensor alarm has to ring. Okay, because that's a restricted area, isn't? It's like an area only selected people can go. So the question says, draw the logic circuit for school alarm system according to the scenario. Note that the door open status equals 1 and alarm status equals 1. Okay. So now when you take this office entrance sensor, computer lab sensor, and storage sensor, okay, a storage room sensor, these are all sensors connected to the door, right? The door can have two states. The door can be open and door can be closed. So the question is saying, consider one to be the door being open. So if one is going to be door is open, that means zero is going to represent what? Because any circuit, any switch or any sensor you take, any switch or sensor will always give you only two values, either zero or else one. Zero means so always the question sometimes might tell you what is zero, what is one. If they don't give it, then you can assume that the positive reason is one, negative reason is zero. Correct. If the question has mentioned that one is representing open, that means zero has to represent that these doors are closed. So close, close, and close. Okay. Note that the door open status equals 1 and alarm status equals 1. So alarm also, we have two functions. So I'll take A is alarm basically. Again, alarm also has two possible results. Either alarm can be on or off. So 0 is, let's say alarm is off. And let's say 1 is representing the alarm being on. Now, if you take to the gates we have, out of all the gates you all have learned, what is the gate that gives the idea that if any of the inputs are true, output has to be true? Perfect. If the office is open, or else if the computer lab is open, or storage sensor. If any of these are open, the alarm should ring. So to represent that, what I'm going to do is I'm going to connect O, C, and S. Okay, I'm going to connect O, C, and S. I'm going to connect all three of them to a OR gate. So OR gate will give you the alarm. OR gate will go and check is either one of the sensors giving a signal. If any of those sensors give a signal, then the alarm will ring. Got it? If student does something like this in physics class, what I'll do in your I can kick them. Even physics class, I can kick them. Can we connect multiple inputs for one gate? If you take AND gate and not gate, sorry, AND gate and OR gate has a minimum of two. So when you say minimum two, you can have multiple inputs as well. When you're drawing diagrams, there is no limits. You can take two, three, four, and all. You can take multiple. But in reality, there are different types of gates. So there are two input AND gate, three input AND gate, four input AND gate. There are different types of gate. So in reality, if you're asking me for two input AND gate, there is a different device. Three, I'll just show you. Two input and get. And three input and get. So in reality, a two input AND gate will look something like 1, 2, 3, 4, 5, 6, 7, 14. 1, 2, 3, 4, 5, 6, 7. Visually, you can't see a difference, but what do you call there's something called two input AND gate, three input AND gate. You have different types of AND gates. When you're buying the AND gate, you will notice what type of AND gate is. So basically, you have AND gates inside this small device called IC. Inside the integrated circuit, you have all these AND gates placed. So if you look at the diagram, you can know in this diagram you can see here for one AND for this gate we have here. For example, if you take this AND gate we have here, there's only two inputs, right? But if you look at this diagram I have here, the diagram I have here, the AND gate which you notice here, this AND gate has three inputs. See, one, two, three. So when you're buying the AND gate, you always specify what type of AND gate you want. Two input Kilekaktina, three input, there's another one. So there are different variations. But when you're drawing the diagrams, minimum two, maximum, you can use any amount. Is that clear? Is it wrong if you use separate gates for all options? How are you going to use separate gates? How can you buy an AND gate? Just like how you go for electronic shops to buy LED bulb resistor. You can buy that as well. It is easy, Amra. Okay. So if you got the diagram correct, you can put another. Wait, this is too much for 4 marks. Make it then ready. I'll give 2 marks for this. I'll give 2 marks here. I'll give 4 marks here. So 4 marks here, 4 marks here, 2 marks here. 1 mark for every this one, basically. Okay. Put 10, 4 out of 10 marks, tell me how many marks you got here, all of you. Why? Lateral, we're marking papers now, we give less marks for easy questions. Amra, we still not learn this in theory. Once we complete the theory, we'll be like, this is Jujupi. Is it wrong if you how are you going to use separate gates? Where are you going to like you mention something else for you can't for one you can't mention for one input, you can't mention one gate. This you have minimum two inputs. So it depends on how you are going to arrange them. If it's one, then it's OR gate. But if it is one, then it's OR gate. I didn't get your question, Tanisha. That's how life is, Amrin. Yes, Isma. Imam, if you repeat the same question, how can I understand? Tell me what do you mean? Like what are you going to put inside the OR gate? Let's if you're going to use multiple OR gates, tell me the inputs for each OR gate. Then I can tell if your answer is correct or wrong. You just keep on repeating the same question. It's not making me understand your question. If you want me to understand your question, tell me if you're going to use multiple gates. For each gate, what is the input you're going to give? What about the alarm system? Why did they give that? Output is going for the alarm system. Zena. The output of this OR gate is going for the alarm system. So alarm system is working depending on the data we're getting from these three sensors. So the data we get from these three sensors, we're going to process it using the OR gate. So OR gate is like a processor used to check is any of these sensors giving us a signal. Is that clear, Zena? That means all should be 1 to be an OR gate. All should be 1 to be. Yeah, Tanisha, I didn't get your point properly, Tanisha. Yes, Amra. how would you write it? Like O plus C plus S? Yes, we write this as A equals O plus C plus S. What about the alarm system? Why did they give that? I will answer that question. Why, Hafsa, why? Why are you sleep? I mean, there's a lot of time to sleep. Okay, basically, like I said earlier, I don't think we can finish on time, so I'm going to drag it as usual. Um, is it like if one is zero, then it's not an OR gate? No, no, no. It depends on the question. We decide what gate are we going to use. The question they mentioned, if someone tries to open these doors, the system should be alerted. So if they say this, if someone tries to open all the doors only, then we are use AND gate. But because they said if someone tries to open the door, like there are three doors basically. If anyone tries to open these doors, alarm should ring. So you have to ask yourself the idea mentioned in the question. If the question says all has to be open, then AND gate. But if question gives you the idea that if any of these open, if the alarm has to be ring, then use OR gate. So depending on the question only we decide, scenario only we decide whether to use AND gate or OR gate. Is that clear, Tanisha? So believe it or not, I had class from morning. I came home after and direct joined us without changing clothes. You think only you join without changing the clothes? I'm still wearing the shoe as well, man. I directly from Kolana how I came. Here I am there here. I started the Zoom meeting in the three wheel. Okay, next. If you all want, I'll give you a small break and I'll discuss the um okay, I'll discuss other questions as well. I'll give a small break and discuss. Let's go on 11 o'clock. I have another option as well, but what else, Alma? Why Amara all this time was silent and now only opening him up. What are the other options? I understandable. Okay, so basically, so far we did only one question, like two questions. The first, so we have now done 30 marks worth of questions basically. But to discuss this, three, four, five, and my plan was three, four, five, and seven, not six, three, four, five, seven. So discuss three, four, five, seven. Anyways, I'll three, four, five, seven. I'll need anyways another 3 more hours. I have another option. Option number one is until 11 I'll discuss and maximum how much? I think around two questions I could discuss maximum in another 1 hour. So out of three, four, five, seven, I discussed two questions. You can tell me what two questions discussed. That's option number one. Again, I can go unlimited as well. Option number two is either on Monday or else on Tuesday from 7:30 to 10 p.m. I'll discuss a balance. I don't mind dragging. I don't even mind doing this class till 4 o'clock, 3 o'clock, 5 o'clock tomorrow. I don't care. I'll be alive. Okay, what option do you all want? Monday or Tuesday then? Understand it. Monday or Tuesday. Okay, I'll put on Tuesday then. So Tuesday from 7:30 to 10 p.m. I'll put the day two. Okay, so the balance question I'll discuss then. Those who have any questions, you all can stay and ask your questions. And the day two of this seminar is going to be on Tuesday. You can ask now. Some of us has have class. You can watch the recording when I'll be giving you all the recording. Don't worry. Anyways, those who have any questions, you can stay and ask. The details regarding the day two, I'll be posting in the WhatsApp channel. So make sure all of you are there in the channel. If you're not there in the channel, I'll just share the channel link so you can join. Dun, 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 dun. When do you sleep? Depends. Today I think I might get late. Anyways, those who have any questions, you can stay and ask others. If you don't have any questions, I can leave. I have a customer convenience still pressure. Why should you again get up, Zaina? What about PDF? I'll be sharing that in the group, Hilas. And by the way, congratulations, Hilas, for that you got some this one, right? I saw you got some award from RI. Fadil, I only play football. I don't watch football. Yeah, good night, all of you. Last Friday, can you please, Muhammad, can you WhatsApp me to this number and I will. Gausan, you can find that actually on YouTube in the Master IT WhatsApp channel. Just go to YouTube, search for Master IT, and I did a programming seminar for 13 hours. You can find there. Day two is a free seminar. Yeah, yeah, everything is free. How do you know anyone? So, do you know anyone called? I might. I don't know personally. Why, Surya? 2023 batch. I have saved the number and kept, but I don't know who that is. You're welcome. Enjoy, Mahira. I saw her name in your class and I asked her. She was like, no. Uh, I don't know. I have that number saved in 2023 older batch, not your batch. So I don't know. Sorry. 13 hours, seriously? Yeah, 13 hours. That is not the highest, man. I have done seminar more than that as well. I think the highest amount of hours I have done a class is I think I have done a class at a stretch for 16 hours. That was my high peak point, including break. So there's a small break in between, but including the break for 16 hours it went. So break was not so huge, but yeah, including the break around 16 hours is I think the time. Yeah. I think I can remember as I can remember. From your batch, I don't know. So yeah. Oh, I think 24 or 25 oral batch. I'm not exactly sure. Was it a final seminar? Final seminar for the oral 25 batch, it broke to 3 days. But if I take the values of the 3 days, if I add the 3 days and see for the final seminar for oral 25, the addition of those three went up to uh, around. Let's see how long it went. 3 p.m. to 4:30. 10 to 5:30, so 10 to 11, 11 to 12, 12 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 7.5 there. And then 10 to 11, 11 to 12, 12 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6 to 7, 7 to 8, 8 to 9, 9 to 10, 10 to 11, 11 to 12, 12 to 1. 15 hours there. 10 and 10, 12, 11, 11, 12, 12, 12 to 1. So 12 and 15. And then 12, 13.5. So what do you call the over 25 batch seminar? It went for 3 days. And the 3 days, the time was first day was 7.5 hours, second day was 15 hours, third day was 13.5 hours. So if you add them together, it's going to be 7.58, 9, 10, 11. 11 plus 5 is 16. So yeah, 36 hours. Technically, like 3 days. 3 days time, final seminar went for uh, all over 25, including the only teaching, huh? Like after, like teaching will finish early. After the teaching is done, I give unlimited amount of time to ask doubts. So these are time the Zoom meeting went. So there were times I was answering these questions. But yeah. Anyways, I'm waiting for your question. Those are IT related questions. I will be answering here. I'm used to it, Fadil. Yes, Samdra. Yeah, there were people. That's why this now this 13.5 hours. This went on until this end. The meeting ended at 4:30 a.m. This 15 hours seminar. This ended at 1 a.m. This one 7.5 hours. It ended early, but these two are late seminars. They were again. The meeting ended early. The people who had doubts only they were waiting till the last moment. And if you have any questions, you can stay as I'm just going to the chat. If I miss your question, just wait a moment. I'm just going one by one, so I might miss. Wait. Exactly, Amra. Uh, yes, Zaina, Lena used to come. What time the seminar starts? On Tuesday, I will be starting your seminar at 7:30. Can you explain the 10th question, fourth one? Yes, I'll explain. Give me a moment. So 10th question, fourth one. Give me a moment, Tanisha. Wait. Jai. Very good, Surya. I requested a week ago. Mohammed is drop a reminder today. I'll just resend. I'll just check and send. Okay. Walaikum salam. Bye. What time do you have physical class, Amra? Explain 10th question. Yeah, Tanisha will explain it. Yes, Salma. Okay, Samat, I replied. Then, okay, I replied. 7 to 9. 7 to 9 p.m. you have class, physical class that was Amra. Who's going to come out to your Where the hell are you going to go at night and do class, man? Yeah, Barakallah. Did I reply all the questions? Hana, when don't you do a seminar for 20 hours straight? Why don't you do a 20 hours? I had to be alive the meant to do 24 hours straight, and then the students has to be alive as well, Hana. So it's a two-way communication. What is Jupiter Anka? That is a planet I own. That is sad life. Yes, but not now, man. Okay, let me come to your question, Tanisha. 10th question, fourth one. Tanisha, talk about this fill handle tool part. Study questions, study questions. What do you mean by that? I'm writing it here. Okay. So the fourth one they have mentioned here, fill method using fill handle tool is not a suitable method to copying formulas. So they said not a suitable method, right? Now, when you're copying formulas, there are two methods. First of all, tell me, Tanisha, are you clear on what do you mean by a formula? You know what is a formula? It's an equation start with equal symbol. So for example, something let's say equals 2 times 3, that's a formula. Is that clear? So this equals 2 times 3 I wrote here. That's a formula. Okay. So when I'm copying a formula, okay, when I'm copying a formula, there are two methods. One is the copy paste method. That's I can either right click and I can click on copy and right click and I can click on paste. Okay. So copy paste method is basically control C and control V. That's the method number one to copy paste values. Is that part clear? Tanisha? Okay. Apart from that method, there's another method to copy paste formulas as well. Can you see a small circle in the blue, like in blue color here? In some software it's circle, some software it's a square. Okay. So if I take my mouse over that, you can see my mouse is changing to like a plus icon. So I can click on that and I can drag it. So when I click and drag, again what happens, you can see the formula has get copied to all these cells. So there are two methods to copy paste formulas. One is you can use the copy and then control C, control V. That's copy paste. Another method is using fill handle tool. I can click and drag. So both are suitable to copy paste formulas. Is that clear? What do you mean by why? Do you mean yes or do you mean why? Ah, yes. Okay. So using that idea in this question, if you say fill method is not suitable. So when they say not suitable, that's wrong. It is actually suitable. If they say it is suitable, then they have said not suitable, it's false. That clear? Okay, perfect. Anyone having any other questions regarding the lesson? Okay, understandable, Amara. Okay, so as there was no other questions regarding this one, I'll again have the day two of the seminar on Tuesday. So with that, I'll wind up today's content and yeah, sleeping as well. So yeah, have a nice day. Bye bye. And yes, thank you for joining. Bye.